G'day, I'm Mark Hoth and welcome to Swift Almanac, where we teach you the basics of Swift in 10 minutes or less. Today's lesson is protocols. So let's have a look at protocols in 10 minutes or less. Protocols. Protocols are a blueprint of properties, methods, and other requirements that are needed for a particular task or requirement. Typically what happens is a class or structures and enums can then adopt the class by implementing the various protocol requirements, and this is called conforming to the protocol. It's probably rare that you'll create your own protocol unless you're developing your own framework, but it's most likely that you'll be conforming to an existing iOS protocol. And that's because if you hear about delegates or delegation, that's in effect a protocol. So to define a protocol, use the protocol keyword, and then you name the protocol, and then you add the requirements between the braces. Now, if you're going to adopt a protocol, then essentially you would have a class called some class, and it would have a superclass, and then you can just comma separate the protocols that you wish to adopt. And so typically you see this in view controllers, where you're going to have text delegates or other kind of delegates that are going to handle controls that happen within your view controller. So in terms of the property requirements, properties can have both type and instance properties. So if you have a protocol called a protocol, we can have a variable that must be settable, which is an integer with get and set, and we have a variable that does not need to be settable, which is an integer with just a getter. And then we have a static variable, some type property, which is an integer which we can get and set. We can have a protocol called fully named, which allows us to get a string, and we can have a structure person that complies with this fully named protocol, and it has the variable string. So essentially what this structure is doing is it's saying that it's going to adopt the protocol fully named, and so it needs to include this variable full name into its data structure. So when we go let John equals person full name John Appleseed, here the struct person conforms to the fully named protocol because it supplies a variable full name that is gettable. Now let's look at the method requirements. You can have instance and type methods, parameters allowed, but there are no default values, as the adopting class will specify the content of the methods. You do not write content, or you do not provide content. So if we create a protocol called the dice protocol, and that will have a method function random to take a double dice and return a double, and we'll have another static function some type method. That's all we need to do. Now we're creating a class called a random generator, and we want it to conform to the dice protocol. We'll have our own class variable called count, which is an integer of number 5, and then we'll have a static function some type method, which is something we need to have in order to conform to the dice protocol. And then we also need this function random, which we also need to conform to the dice protocol. And so we create a function called random, which takes dice double and returns a double. And in our case, it's going to return the dice times this count function. It's obviously not too random. But essentially the point is that by creating this function, we're conforming to the protocol. So what you need to wrap your head around here is that the protocol is just a blueprint. It says you must have a function and it must have these parameters and return this value, but how it does that and what it does with those parameters and how it returns the value is totally up to yourself. So So just returning double count still means that we're conforming to the function because we have the parameter and we're returning a double, and that's what the protocol requires. Okay, so let's look at the mutation of data properties. If you are adopting a protocol in a class, then you don't need to worry about mutation changing instant variables. If you're adopting a protocol within a struct or an enum value references, then you need to mark the method as mutable. You need to spell it correctly, like that. So if we create a protocol toggleable, and it's a mutating function called toggle, and we have an enumerator which is called the on-off switch, and it conforms to the toggleable protocol, then we have the case of off and the case of on. We have our mutating function toggle, which we need to have from the protocol because we're conforming to it, and then we switch self case on. If that's the case, then we'll change our self to off, and case off will change our self to on. And note that in order to mutate, you must use a variable, not a constant. So down here we can have a variable light switch, which is the enumerator on-off switch, and we'll set it to .off, and then light switch .toggle. That's going to change case off to case on, and there it is over here on the right. Protocol initializers. You can have a protocol called init protocol, and it will have an initializer and some parameter in it. And when you're adopting a protocol with an initializer, you need to specify that the initializer is required by the class, regardless of whether it is a designated or a convenience initializer. So class, init class, to conform to the init protocol, we need to put this required init some param int initializer, because if it's not required, then we're not actually complying or conforming to this init protocol. In terms of coding management, it is really useful to place all of your protocols in a separate extension file. This isolates all the code relative to the protocol into one source file and / folder. So if we have a protocol called text representative and we have a variable text description, which is a string which we have a getter for, we can create an extension of our class, init class, which conforms to the protocol text representative, and we have our variable in there with our getter. Protocols can inherit from other protocols, but I don't recommend that you do this. It's very hard to manage. So if we have a protocol inheriting protocol from some protocol, define our properties here, then class only protocols are forced when a protocol inherits with any object. So if you have a protocol of some class only protocol that is attached to any object, then you define your properties and methods there. And if it's class only protocol, then it's going to fail if you try and access it to a struct. But if you've got good adoption of the some class only protocol, then as you can see, everything's all good. Finally, we have optional protocol requirements. Some protocols will list several methods, but only a few are required and the others are optional. Here we've employed Foundation and we've got an Objective-C protocol with optional method. And you can see here it just has the at Objective-C optional keyword. So this variable would be optional, but this variable would be a must-have. And you must have this function, but again, if it's got the at Objective-C optional function, then that function would be optional. Well, that's it for protocols. If you have any questions about the tutorial, then please leave a comment below or hit me up on Twitter @SwiftAlmanac. Please subscribe to the channel, it's free, and check out our website at www.swiftalmanac.com. Thanks for watching, and we'll see you next time. Cheers.